Okay, let's take a look at how to approach questions around enzyme efficiency for the MCAT. So first of all, there are a few equations that we have to have on top of our mind for the exam, such as Vmax is equal to the enzyme concentration times Kcat. If you want a mnemonic, I remember it as speedy cat or scary cat. Why? Because cats run fast, and if I see them, I'm like, eek, there's a cat, right? Eek, cat. So, well, for whatever that's worth. And then this is a more complicated formula, but this usually doesn't come up. What the questions are around, I feel, what the content that the AAMC creators seem to care about is this more around efficiency, right? And this part of this equation, this is just velocity, that was Vmax, this is just velocity at any point. They care about the efficiency, the catalytic efficiency, but you might as well just call it efficiency, right? So the questions are around how is the efficiency of the enzyme related to the measurable variables such as Kcat and Km, which is the Michaelis-Menten constant, I believe. So really, when there's a question about efficiency, the first place your mind should go is that efficiency is correlated to Kcat over Km. Now let's break that down how it's correlated, right? What does the correlation mean? So if Kcat goes up, if the number, whatever number that is increasing, then there's a direct correlation. Kcat is increasing, your efficiency is increasing, right? You can see that right here in the equation, I hope. And then for Km, which is in the denominator, if only Km is decreasing, then my efficiency would go up. So that's an indirect relationship, right? So if Kcat goes up, efficiency goes up. If Km goes down, only then does my efficiency go up. And now sometimes they word it in terms of affinity. They will not tell you what the Km is, but they will say, oh, the affinity is increasing. Km and affinity are opposites of each other, right? So if Km is decreasing, that means affinity is increasing, right? So if it's the opposite, then you kind of just go around and you come about the same thing, which is like, well, if affinity is increasing, then Km is decreasing, and according to this equation, if Km is decreasing, then efficiency is once more increasing. So you can draw all these conclusions by remembering this equation. And once you have that in your head, you may get a question like, oh, okay, here's a graph, here's some data, and you're supposed to determine which one is the most efficient enzyme, right? And you're given various isotopes or isomers, and you have to figure this out. And you go to this equation, and before you get it too convoluted, your first should be, I'm looking for Kcat and Km, right? Now Kcat is associated to Vmax, right, directly. So if Vmax goes up, then Kcat goes up, and if Kcat goes up, the efficiency goes up. So yeah, you could start looking at the Vmax column. But what you notice is it's 20, 50, 10, 60. That's all in the same zone. That's 10 to the power of 1, right? Those are all in the same zone. Whereas Km is like jumping between, different like thousands, hundreds, tens. So this is probably worth focusing more on. This is going to show us a bigger change, mathematically speaking. Also, Vmax is an indirect relationship to Kcat that trickles down here. So keep it simple. Just let's look at Km. What's Km doing? So in here, which one might have the best efficiency? Well, we want the Km to be really small. Now, which of these is small? And sometimes people miss this. 10 to the negative 1 is 0.1, 10 to the negative 2 is 0.01, and 10 to the negative 3 is 0.001. And if you're in an exam and you're panicking, it helps to write this down. So you can see that the bigger negative power is the smaller number, and we want Km to be as small as possible. So the smallest one is right here. So this would be the most efficient, right? And 10 to the negative 6 would be big enough to make a dent that you wouldn't care about any of this stuff. So that wouldn't matter. Now let's say we were not, let's say we were not given this column, right? How would we make our decision then? Well, in that case, if those numbers didn't exist and all we had was Vmax, then we can make our decision saying, oh, okay, Vmax is related to Kcat. So, Vmax. So if Vmax goes up, that must have happened because KCAT went up. How are we doing that? Just like this was a direct relationship, KCAT efficiency, KCAT and Vmax is a direct relationship. So if Vmax goes up, KCAT goes up, so efficiency goes up. So if as long as I'm looking for the highest Vmax, all other things being equal, I must have the most efficiency, or I must be the most efficient. In that case, this would win. You're assuming Km is the same for all of them. Well, then clearly, if Km is the same, then the fastest enzyme obviously has the most efficiency. So 60 wins, right? But that's really a corner case where you don't have Km, or you're saying the Km is exactly the same. That's not necessarily the case when you have Km available and it's differing by such large degrees that Vmax doesn't even matter, which is all in the tens place. Okay, I hope that makes sense.